We're going to factor trinomials where the lead coefficient is not a 1. And we start out in a way that looks similar to what we used when we were factoring trinomials where the lead coefficient was a 1, but then there's a lot of extra steps that we're going to have to do. We're essentially going to end up factoring this thing by using our grouping technique. And if you recall, when you use the grouping technique, you have to have an even number of terms, because what you do with grouping is you divide your whole polynomial into pairs. And we only have 3 terms here. We have the 6x squared, the 13x, and the 6. So the strategy for this technique is to find 2 terms to replace this one middle term. So 2 terms that actually will add up to 13x. And we want to find the right 2 terms to make our problem work out correctly. So not just any 2 terms will do. We don't know if it's going to be 1x plus 12x or 2x plus 11x. So a lot of this is just figuring out what is the perfect pair that will replace that 13x. So we start out by drawing our 2 trees, just like we did before. And the first tree, we get the number that we want by multiplying the a and the c coefficients. So 6 times 6. So we're multiplying a times c, and that's equal to 36. So at the top of our first tree, we're going to write 36. And recall our first tree is where we're trying to find 2 numbers that will multiply up to the top, which is 36. So we're looking for 2 numbers that will multiply together to get 36. And then we're still going to use the middle term of 13 for the top of our second tree, and just like before, we're looking for 2 numbers which will add up to 13. So we want a pair of numbers which will multiply together to get a 36, and those same 2 numbers will add up to 13. So you can start trying combinations. You might think, okay, well, 36 is, let's see, how about 3 times 12? So we try 3 times 12, and yeah, that does multiply together to get 36, but then when we add the 3 and the 12, we get 15, and that's not what we're looking for. We're looking for 13. So this isn't going to work. So we try different combinations, and it turns out that the combination that does work is 4 and 9. 4 times 9 is equal to 36, and 4 plus 9 is equal to 13. So now our next step is going to consist of using those 2 numbers that we just found to replace this middle term. So I'm going to rewrite my trinomial, except that I'm going to expand it to have 4 terms. So the first term is going to stay the same. The last term is going to stay the same. And in the middle, instead of 13x, I'm going to write plus 4x from one of those numbers that I just found, plus 9x, and that comes from the other number that I just found. Now we have 4 terms, and now from here we can go into our grouping technique. Now you might ask, does it matter with this 4x and 9x, does it matter which order I write them in? And no, it doesn't. You're going to come out in the same place no matter which order you write them in. So now recall the next step in grouping is to pair up the terms. So we have 6x squared plus 4x, and we have a 9x plus 6. We start by trying to find the greatest common factor of the first pair. So for 6x squared and a 4x, our greatest common factor is going to be a 2x. So we're going to factor that out, 2x. And so 6x squared divided by 2x leaves us with a 3x. And 4x divided by 2x leaves us with a 2. Now we look at our second pair of terms, and we're going to factor out, it looks like a 3 is our greatest common factor, a positive 3, so we're going to write a plus 3. And when we factor that out, we have 9x divided by 3 is 3x, and 6 divided by 3 is 2. So we're getting close now. Remember that the grouping technique only works when these two terms are exactly alike, and sure enough they are. So those two terms, that gives you the first factor in your answer. And once you factored that out, what you have left gives you the second factor. So we have 2x plus 3. And just like we did before when we were factoring, you can check your answer by foiling that. So foil that out. Foil out 3x plus 2 times 2x plus 3, and make sure that you get back to your original problem, which is 6x squared plus 13x plus 6. All right, let's try another example. Let's try something where we have to work with some different signs. So what we're going to do here is we are going to use 6x squared minus 7x minus 3. So that will give us a little bit of a challenge for our signs. So let's start by drawing our two trees. And the first number will be negative 3 times 6. So we're multiplying 6 times the negative 3, and that gives us a negative 18. And then the second number, we're going to come right from this middle term of negative 7. So now we're looking for two numbers that will multiply together to get a negative 18, and that will add to get a minus 7. Now we know that when we multiply, if we want to end up with a negative number, then one of our numbers has to be positive and one has to be negative. So it turns out that the two numbers that work here are a negative 9 and a positive 2. If you multiply a negative 9 times a positive 2, you get a negative 18. And if you add a negative 9 plus 2, you get the negative 7. So negative 9 and a positive 2 is what's going to work. So now recall that what we do with those two numbers that we just got, we use it to expand our middle term. So rewriting, we're going to leave the first term and the last term as is, and we're going to replace this negative 7x using the two numbers we just found. So a negative 9x plus 2x. And now we proceed using our grouping technique. So pairing them up, we look at our first pair. We have 6x squared minus 9x. Our greatest common factor is going to be a 3x. So we'll go ahead and we'll factor that out. And what we have, the first term is going to be 6x squared divided by 3x, which is 2x. The second term is a negative 9x divided by 3x, so that's going to give us a minus 3. Now let's look at this second pair, 2x minus 3. There is no greatest common factor other than 1. So a 1 is exactly what we're going to take out. So 1 times 2x minus 3 is going to give us our 2x minus 3. And finally, we're ready to put together our answer. So we're going to factor out our binomial factor here. 2x minus 3 is our first factor, and once we factored that out, what we have left is our 3x plus 1. And check by foiling. Foil that out and make sure that what you get back is your original problem, which is 6x squared minus 7x minus 3.